We are excited to present our project title House Price Prediction using a linear regression and decision tree. This work has been done as a part of our machine learning course. Myself, Deepak JM. My teammates are Manoj MS, Nandivardhan, and Vikas. Today, we will discuss about this table of the contents. Uh, First, we will discuss about the introduction. In today's, in today's real estate marketing, price house accurately in challenges due to multiple influence factor like location, size, and market demand. Our project addressing this by using a machine learning algorithm, especially linear regression for the simplicity and a decision tree for the flexibility to build a models that can predict house price with good accuracy. Uh, let's see discuss about a problem with we are trying to solve. First one is predicting house price is not easily because there are many influencing features. Manually methods are slow and subjective. We need to model that are both interpretability and reliability. And the data we use often messy with missing or incomplete files. Also, reboost my model, but must be able to handle both categorical data like neighborhood type and numerical data like square footage. Uh, our goal is to addressing their all challenges with machine learning. Uh, Next part will be continued by Nandivardhan.
Next slide is about objectives. In this, first one is build and compare linear regression and decision tree models. We build decision tree model and linear regression models to understand effectiveness in predicting house prices. We aim to evaluate them using key performance metrics such as mean absolute error, root mean squared error, and hazard error score. And the key objective was to develop an interactive interface where users could input data and get predictions. We also provide insights to the with the features most influencing house prices. And next slide. And the next slide is system design. We start with the user input, which goes into the pre-processing module. Here, the data is cleaned, encoded, and prepared. Then it passes through the modeling engine, where both the linear regression and decision tree models are applied. After prediction, the evaluation module measures performance. There's also a GUI layer designed for real interaction and entire which handles this components. So the next slide is about methodology. Uh, our methodology is followed a clear step-by-step process. We begin with data collection from different data sets. Next, we clear the data and handle missing values, followed by feature encoding to convert categorical values into numerical ones. Once pre-processing was done, we selected relevant features and moved on to a model building and evaluation. Algorithms used. In this, we used linear regression and decision tree. Linear regression, which is simple and interpretable, making it a great baseline model. However, it's sensitive to outliers and assumes that the data has a linear relation. On the other hand, decision tree, which can mo- which can model non-linear patterns and gives better insight into feature importance. It's more flexible but can be prone to overfitting if not regularized. By comparing both, we could identify the strengths and weakness of each approach in the context of house price prediction. The next slide will be continued.
Implementation in Python I use it for coding and modeling. Libraries like Pandas, NumPy, and also it has steps used in implementation. Load and clean dataset, feature encoding and scaling. train test split and model training and evaluation, generate evaluation plots for metrics, and also it prepares a GUI for user testing. Next slide. Model evaluation. Linear regression, like in linear regression, assumes a linear relationship between features and target, and it is easy to implement and interpret. Performs well when data is linearly correlated, and it uh, mm, it also used decision trees and also metrics used like R square, and it compares training and versus test performance to check overfitting. Next slide. Tools and technologies. In tools and technologies, like it used Python, Jupyter Notebook, and VS Code. Like libraries like Pandas, NumPy, and optional. It is streamlined for GUI. It is only optional. GitHub for version control and collaboration. Next slide. Conclusion. ML enhances accuracy in house price prediction. It has more accuracy in house price prediction. And also linear regression. It is a simple baseline. Decision tree is suitable for complex data, or not only for simple data. It is also suitable for complex data, and practical implementation with proper pre-processing. A scalable solution for modern related analytics, uh, effective combination for of ML and domain knowledge. So next slide. References. These are the references. Code will be explained by Manoj.
Okay, I am here to explain the code part. Here, initially we have to import some of the libraries, Python libraries, Pandas and NumPy. Pandas used to analyze the data from the Excel and all the another worksheets. NumPy is used for numerical operations like roots and squaring the some of the numbers and all. Then the SKN is also an machine learning library. It is used to split the this when train in this line from sklearn model selection import train test split. We are used to split your data set into training and testing sets. And fourth line, from scalar linear model, import linear regressions. Here the imports the linear regression model of by sklearn model sklearn dot linear model. Sklearn tree. It here imports the decision tree regressor. Then the another six line code from SQL matrices, import mean absolute error, means squared error. R square is importing the mean the MAE, MSC, and R square. I will explain these three in these three definitions. Uh, Another part. Then the data. Here the data set is allocated to this keyword. Uh, Next line. Here loads the data. Yeah, for X keyword, it drops the price column and keeps the rest as futures. Then in Y data of price, it allocates the price column in Y. X X Y X test X Y test, all are the train and test uh, model. Here 0.2% is on the test size, and a random state is 42. 80% of the training data is here. 20% of the testing data is ensures the random state is equal to 42 ensures the same split every time for consistency purpose. The trying linear regression model, it it creates a linear regression model object, uh, linear regression model. Then the LR model fit X train X Y train is trains the model on the training data and testing training data only on testing the training data of X and Y, and then the Y predict LR is equal to LR model predicts X test is price the prices using the test data. Whatever the data is given in data set, it will predict on the basis of this data. Data model here data model decision tree regressor. It is maximum depth of 5. Create a decision tree regressor maximum depth of 5. It limits the tree complexity actually. The data model fit by train fits on the training data, fits the model training on the training data. Then why predict data model predicts the pricing using test data. Here the train actually predicts, then the function is predict are the arguments here. Here the name and y predictor is arguments. Whenever the calculation is done on the basis of the evaluation, it will print evaluation value. Then the another line ME. Here the ME means average of observed errors. It actually calculates the averages of the absolute difference between actual and predicted values between. Whenever the smaller ME gives, it betters the model. And next RMSC is root mean squared, similar to ME, but squares the error first and giving more weight and larger errors. It helps to maintain the data accurately. It R square is helps to how your model explains the variability of the on the target model. And then it is only range between 0 to 1. If the 1 is came means, then it shows perfect predictions, nearly 1, not exactly 1. Then the if it contains 0 means, it will shows as model does not better than the mean, like that method. Evaluate model. Then the evaluate model, linear regression and y test data, y test, y predictor LR. In this line, it will actually evaluate model function to print the performance of linear regression, and another line evaluate model prints the evaluate model calculation of decision tree regressor. I will run this code now. Here I am actually initially copied the path here. On the basis of MEE7686. It is predicting linear regression value. MEE means what mean absolute error. It is having value like this. Then the RMSE value like this. R square is initially before some hits I said what one it is nearly to equals to one. What? Yeah. Perfect predictions. The one indicates the perfect prediction, and then a decision tree regressor evaluation. Here, mean absolute error. It is having a value like this. A root mean square error value is like this. R square score is nearly equal to one. Then it's perfect. It's showing perfect predictions. Okay, this is our code. Thanks to all.